Okay, so we're going to do the same thing here, put it into standard form. But the difference here is that it's going to be passing through a point, and this time it's perpendicular, not parallel to this line right here. Okay, so first we want to find the slope of this line. So this, you can put it into slope-intercept form, or you can use that shortcut I talked about. So opposite of A over B. And watch your signs there. We end up with 3/4. So this means the line perpendicular to that, there's this abbreviation for perpendicular, is the opposite reciprocal. So this would be -4/3. Okay, so this is the slope that I want to use. And now I also want to use this point right here. So I've got y equals -4/3 x plus b. And now I'm going to substitute in -2 and 3 for x and y. So x is -2, y is 3. Oops, -2 plus b. Okay, so I get 3 equals 8/3 plus b. All right, and now I want to take and subtract 8/3 from both sides. So you're just going to go, you can take your calculator and just go 3 minus 8/3. And then convert it. You're going to get 3 is 9/3 minus 8/3 is 1/3. So you should end up with b is 1/3. Okay. All right, now I can write my equation all the way through it. The only difference is it's not in standard form, it's in slope-intercept form. Okay, so standard form just means I want to make sure that these are not fractions, they're just integers. So in order to do that, you want to take this whole thing and multiply to get rid of those denominators. So you can see both the denominators there are 3, so I want to multiply this by 3. Basically, you want to find a common denominator, get rid of it. So now if I just multiply that whole thing, all those fractions will be gone and you don't have to mess with them. So that's kind of nice. So I have 3y equals, multiply this, 3 times -4/3 x, and just the denominator is just going to drop out. And then same thing here, plus 1. And now magically we have no more denominators. So then the second thing is you want to just make sure that your x and y are on the same side. So I want to move -4x to the other side. So I'm going to add 4x to both sides. So I'm going to get 4x plus 3y equals 1. Okay, now they're all integers. I want to make sure that this is positive. Okay, it is, so we're good. Let's just, for a moment, pretend that it wasn't good. What would you do? So let's say, for an example here, I had -7x plus 2y equals 3. Okay, all you would do is just change the sign on everything because you want to change that to a positive 7x. So that means you have to do that to everything else. So then you would just have this. Whoops. Kind of went haywire there. All right, equals -3. All right, so that's what you would do if this were negative. Then you just change everything else so you can change the sign on that. But anyways, that was just an example just in case you run across that. So this would be my answer for this problem then. A line that's perpendicular to 6x minus 8y equals 5 and passes through the point -2, 3. All right, hope that makes sense.